Hi everyone, this is Ashwin. In this video, we are going to analyze the dataset Turkey student evaluation. So I'm going to use clustering in the dataset. So far, we have seen only supervised learning. Now we are going to see unsupervised learning. That means we don't have any output variable to predict. So we are going to cluster the input points from the dataset and assume this cluster belongs to this output. Like that, we can do some inference in the unsupervised dataset. That means we don't have any output variable. Okay, let's see about the dataset now. This dataset contains a total of 5,820 evaluation scores provided by students from Gazi University in Ankara, that is Turkey. There is a total of 28 course-specific questions and additional 5 attributes. So these are the attribute information. So we have 28 questions and these are the additional 5 attributes. Let's see the 5 attributes, that is instructor, instructor identifier that values from 1 to 3. So we have only 3 instructors. Class, that is course code, values taken from 1 to 13. That means we have 13 separate classes. Repeat, number of times the student is taking the course. Values taken from 0, 1, 2, 3 and it goes on. And the next one is attendance, code of level of attendance, values ranging from 0 to 4. Difficulty, level of difficulty of the course as perceived by the students. Values taken from 1 to 5. 1 is easy and 5 means it's very difficult. Like that, we can get an assumption from the values. And these are the 28 questions they asked to the student about the course and the respective instructor. So as you can see, the first few questions related to course and textbooks and some general questions. And these questions are related to instructors from 13 to 28. All the questions related to instructor. So from question number 1 to question number 28 are all Likert type, meaning that the values are taken from 1 to 5. This is almost similar to rating. So 5 means it is better rated and 1 means it is poor rating. Like that, the values are given by the students. So these are the data available for us to do the analysis. So here there is no output variable, only the input attributes are given. From this input attributes, we need to get some analysis and do some inference. Okay, let's start coding now. First, we will import the necessary modules. Import pandas as pd, import numpy as np, import seaborn as sns, import matplotlib dot pyplot as plot, import warnings, and for matplotlib inline warnings dot filter warnings ignore. Apart from this, we need to add another line, that is pd dot options dot display dot max columns equals 99. I'm using this line because we have so many number of input attributes. We need to see those values. If you don't specify this line means it will just ignore some of the data values in the data set. So we can see all the values in the data set. If you have more than 99 attributes means you just need to increase the number. Let's run this. Okay, there are no warnings here. Let's load the data set now. df equals pd dot read csv. The dataset name Turkey student evaluation generic .csv. Let's display it. Now these are the dataset values. So these are the 5 attributes. As you can see, the values are ranging from 1 to 3 for instructors, 1 to 5 in difficulty, and all the question values are in the range of 1 to 5. So we have values up to 1 to 28 questions. Okay, this is a general overview of the dataset. Let's analyze it further. To display the statistical info df dot describe, run this. This will give us a statistical information about the dataset. we have count, mean, minimum and maximum. So we can decide the range of values. So in questions, you can see the mean is around 3. If you scroll down the entire data set, so all the attributes have the range of 3. So that means the average rating the student giving is 3. Like that, we can get some inference, and we can also do some other analysis. These are some interquartile range. So you can also plot some graphs to see which ranges have maximum number of counts. Like that, you can analyze it further. Now let's display the data type info. So data type info, df dot info, run this. So here all the data type values are integer. So we have integer 64. We have only 5,000 samples in the data set. If we have millions of samples in the data set, means the memory usage will be much higher. It may go to in terms of like 5 to 10 gigabytes based on the number of samples. For that, in order to optimize it further, as you can see, the values are ranging from 1 to 5 alone, not more than that. So you can just change the data type to int 8. That means int 8 bits. So it can support up to 2 to the power of 8 values. Now it's in the maximum range, that is 64-bit. So it takes a lot of space compared to int 8. If you change the data type for all the columns, means it will reduce the memory further from 1.5 MB to some kilobytes. You can try it if you want. We will definitely use some advanced pre-processing techniques in the later videos. So let's do the pre-processing. First, let's check for null values. Check for null values. Df dot is null dot sum. Run this. So there are no null values in the data set. If we have null values, means we can just fill the null values using mean or mode. Now we can just ignore it. Let's go for exploratory data analysis. I'm going to set some new styles for the plots. Set new styles for the graph. Plot dot style dot use 538. This is one of the style I mostly prefer. So let's run this. Now let's do the analysis. So SNS dot count plot. Let's say df of instructor. Run this. As you can see, instructor 3 had taken more number of courses compared to instructor 1 and 2. So we don't have name here, but it is obviously clear that is instructor 2 has taken more courses than the combined count of other instructors. Okay, let's do some more analysis. SNS dot count plot df of class. Run this. So these are the number of students in that particular class. So in class 3 and class 13 has higher number of counts than all the other classes. For some classes like 2, 4, 7 and 12 has only few number of students enrolled compared to other classes. As I already mentioned before, we can see in the questions the mean of all the questions is C. Let's do the analysis and visualize it further. Find mean of questions. I'll say X questions equals df dot ilog. We need to get all the rows for the columns from 5th column to 33rd column. Now Q mean, that means question mean, equals X question dot mean access equals 0. We can also compute the total mean of this particular Q mean. So total mean equals Q mean dot mean. This will compute the mean of means. And after that, we need to convert this quotient means to a data frame. So let's run this for now and convert this quotient mean to a data frame. So q mean equals q mean dot to frame. That frame value will be mean. And q mean dot reset index level equals 0 and in place equals true. You can also use in place here instead of like assigning like this, or you can use in place equals true. Both are same. You can use anything you want. Now let's display the mean. So qmean dot head. So this is the index, these are the mean. So for q1, this is the mean. For q2, this is the mean. Let's display the total mean. Total mean. So the total mean of means is 3. As we already explored that before. So the total mean is 3. So the average rating that the student gave is 3. Let's plot this means in terms of graph. So SNS dot bar plot x equals index value, y equals the mean, data equals the q mean. Okay, let's run this. Okay, it's displaying it, but the x-axis is so much constrained. So let's make the graph larger. For that, plot dot figure fig size equals, let's say 14,7. Run this. Okay, now we have a clear view. These are for each questions. I'm displaying the mean. You can also compute any other statistical info you want, like standard deviation, variance, minimum, maximum, like that. You can compute any attributes you want and convert this into a data frame and plot it like this. Okay, that's it for exploratory data analysis. Now for the correlation matrix, as we already said, all the values are integer only. So all the columns will be subjected to input for the correlation matrix. So core equals df dot core, sns dot heat map correlation matrix, and anot equals true to display the values, and cmap equals cool warm. You can use any color map if you want. Let's run this. Okay, again the picture is somewhat constrained. Let's just copy this figure size and paste it here. Run this again. Okay, still it's much in constrained manner only because of so many number of attributes. Let's increase the values further. For the columns, let's say 12. And for the rows also we need to increase, let's say 18. Run this. Still, I guess we need to enlarge the columns further. Let's say again 18. Now it is somewhat clear, but still it's somewhat overlapping also. Here, warm color is positive correlation and cool color is negative correlation. For all the questions, we can see a positive correlation between them. And for the first 5 attributes, that is instructor, class, repeat, attendance, difficulty, for all these attributes, we are seeing a negative correlation with those questions. And even for them, it is also in negative correlation only. We already discussed that in supervised learning, if we have so many attributes means we will ignore some attributes based on some positive correlation or negative correlation. But here I'm going to use some different technique. So I won't delete any attribute in this data set. Instead of that, I'm just reducing the dimension of the attributes further. For that, I'm going to use principal component analysis. Principal component analysis is a good technique for data reduction. If we have higher dimension data, like here, we have dimensions up to 28. We want to include all this data, but in a reduced dimensions. So from this 28 dimension, it will reduce it to 2 dimension. So we can visualize the attributes in terms of graph. You can also reduce it to 3 or 4 based on the constraint we have. And if you have like millions of attributes means this is a technique you will be using to reduce the number of attributes. So this will greatly reduce the computational time to train the model, and it will also retain the information of the data set. Let's use the technique now. Before using the technique, we need to get these 28 questions. So that is the input for us. X equals df dot ilog of all the rows we need to consider for the columns 5:33. After getting the input, we need to import a module for PCA from sklearn dot decomposition import PCA. Now PCA equals PCA n components, that is the number of dimensions we need to reduce. So n components equals 2 and random state equals 42. Now let's fit the data set and transform it. So x PCA equals PCA dot fit transform x. So there is a difference between fit and fit transform. If you just say fit means it will just fit the data set and assign it as a model. If you use the function fit transform means it will fit the dataset in the model and transform the inputs based on the number of components. Here number of components is 2. From 28 attributes, it will just reduce the number of dimensions to 2. Let's run this. Now we have ran the dataset. Let's see what is inside the dataset. XPCA, run this. So we have only 2 columns with all the samples. These are the reduced attributes. Let's see how much information we have retained from the dataset. Let's leave some space. So this is how much info we retained from the dataset. So PCA dot explained variance ratio dot come sum of 1. Run this. So we have retained up to 86% of information. Typically, if you use some other data set for supervised learning and you have like more than 50 or 100 attributes means, just maintain the ratio up to 95%. We need to retain at least 95% of the original data for better processing. Here, we have reduced it to 2 dimensions so we can visualize it with our eyes. That's why we are taking up to 86% of the data. So it won't affect the model that much. We will explore it further, how data reduction affects the model. Okay, let's use the clustering mechanism. So I'm going to use K-means clustering. We need to import a module for that from sklearn dot cluster import K-means. I'm going to create an empty list called distortions. So distortions equals an empty list. Distortion is like a metric in cluster. Like in supervised learning, we don't have any output variable in this data set. In order to find a best model, we need to pick the model with less number of distortions. After that, we need to try different clusters. So I'll say cluster range equals, the range starts from 1 to 5. So this will return a range. Now let's do some training and find a better model. So for I in cluster range model equals K means n clusters equals I. So for each iteration, the number of clusters varies. Now init equals Kmeans plus plus. These are some hyperparameters. If you don't want to specify it means it's fine. It will take the default hyperparameters, and n jobs equals -1. N jobs relates to parallel processing. If you specify -1 means it will use all the cores in our CPU to process the model. So the model can train much faster. And lastly, random state equals 42. Now after defining the model, we need to fit the data. So model.fit, that is xPCA. Now after fitting the model, we need to append the distortions. So distortions dot append model dot inertia. So this is the distortion value we'll be getting from the model, and I'm going to append this value to the distortions. Let's run this now. After running the model, we need to plot the distortions. So plot dot plot cluster range, that is x-axis. Now distortions, that is y-axis. Marker equals O. Now we need to specify some labels for the graph. So plot dot x label, number of clusters. Now plot dot y label, that is distortions. Now plot dot show, run this. So finding this number of clusters, this is called elbow method. As you can see a elbow shape here, and from this distortions we can find the number of clusters. We will take the number of clusters in the joint of the elbow. This we will consider as a joint and take number of clusters as 3. Now we will use 3 for the cluster. Let's copy this and paste it here. Number of clusters is 3. Use best cluster. Now after defining the model, again we need to train. Fit is equal to xPCA. After training the model, we will try to predict the output. That means this sample point belongs to which cluster. Like that we will get the output. So y equals model dot predict xPCA. So this will store the output. Let's run this. Let's leave some space. Now we need to plot the graphs in order to see it visually. So this will take some time, I guess. Plot dot scatter. I'm going to use scatter plot. So x PCA. This is for x-axis. So y equals 0. We are taking the points belongs to first cluster. So this is for the row and this is for the column. And again xPCA, y equals 0 and the column is 1. Now we need to set some parameters. S equals 50 and C equals red. This is the color for that cluster point, and label equals cluster 1. Similar to this, we need to do this for 3 clusters. So this output label will be 1 and this is also 1. You can change this as yellow and this is cluster 2 and this label is 2. This will be, let's say, green, and this is cluster 3. Now we need to define the title and labels. Plot dot title cluster of students. Plot dot xlabel PCA1 because we have reduced 28 dimensions to 2 dimensions. So we have only 2 columns. So plot dot ylabel, now again PCA2, plot dot legend to display the color for that particular cluster, and plot dot show. Let's run this. So this is the x-axis, y-axis. We have 3 clusters here, and we have missed the centroid of the clusters. Let's add it now. So plot dot scatter model dot cluster centers of, need to get all the rows. So this is for x-axis, and again model dot cluster centers, need to get all the rows, and this is for y-axis. So this will be rows, this will be column. You can specify some ranges if you want to do some other processing. Now again, yes equals, let's make it somewhat bigger. So let's say 100. This is the size of that point. So this is size 50. So I'm making the size as 100. Now we need to have some different color. Let's say blue, and label equals centroids. Let's run this. Now we have 3 clusters from the data set. This is the center of the cluster. So if any new point comes to the data set, means it will just calculate the nearest center and assign to that cluster. Let's say if a new point appears here, means this new point closer to cluster 3. So it will assign the point to 3. So if the point appears here, means it is closer to this cluster. So it will assign this point to this cluster. Like that, we can make some assumptions, and we have 3 clusters, right? So we can give some output variables for each cluster. Let's say if the output variable is in red, means the students are much dissatisfied. If it's in the middle, means it is in the neutral state. And on the right side for yellow, you can see they are satisfied. Like that, we can get some output variables from these groupings here. Let's see how many points belongs to each cluster. For that, we need to import a module from collections import counter. This is a dictionary module. So counter of y, run this. So for cluster 2, it is 2360. For cluster 0, it is 2220. And for cluster 1, it is 1240. So 0 belongs to this cluster, and 1 belongs to the yellow one, and 2 belongs to the green one. So we have more number of candidates in the green one, that is in the neutral state. So these values are generated from 2 dimensions only. Let's train the model with the entire data set. So let's copy this and paste it here. Instead of XPCA, we will just use X. That means we are training it with 28 dimensions. Let's run this. Now again, counter of Y. If you want to store this model in a different variables, means you can use it for later processing. I'm just replace the model. Let's run this. As you can see, only one sample is different. Here it is 60, here it is 59. So that one sample belong to 0. As you can see, even if we train it with 28 dimensions, we are not seeing that much difference in the output. So we don't need to worry about that. We can just train it with only 2 dimensions. And this is elbow method. So I'll just comment it. Elbow method. We have used elbow method to determine the number of clusters. We have another method to find the number of clusters, that is dendrogram. Dendrogram. For this, let's import a module. Import sci-fi dot cluster dot hierarchy as higher. Now dendrogram equals higher dot dendrogram higher dot linkage XPCA, that is the data set, and method equals word. So you can use any method if you want. So based on the method, the output may differ. So this is the default syntax to find the dendrograms. So this will automatically result a graph. So let's add some labels to that. Plot dot title, that is dendrogram. Plot dot x label, that is questions. Plot dot y label, that is distance. This will compute a Euclidean distance. Based on the distance only, we are going to determine the number of clusters. And let's plot the graph. Plot dot show. Run this. It will definitely take a time, so just wait for a while. So after a minute, we got a graph like this. So based on the color itself, we can determine the number of cluster is 2. So this red one is one cluster and this yellow one is another cluster. From elbow method, we have determined the best cluster is 3. From dendrogram, we have determined the best cluster is 2. Let's do some processing with the number of clusters as 2. So for this, I'm going to use agglomerative clustering. Let's import that module from sklearn.cluster import agglomerative clustering. So this dendrogram is also works on like agglomerative clustering. You can see the graph is combining on each part, right? So this is combined and this is combined and this is combined and finally this is combined. So each is determined as a cluster. So each cluster is combined as one. In the final, all the data points belong to a single cluster. So based on the Euclidean distance, whichever has the highest distance, you can just split it and take this as a cluster. So this will go in detail in theoretically. You can just explore it in detail using some blocks later on, but it works simple as that. It will just make some individual small clusters and combine it until it makes a big one. So let's train the model. Model equals agglomerative clustering, n clusters equals 2. Now affinity equals Euclidean because we are taking Euclidean distance only. Euclidean and linkage equals word. So we have taken the method as word. That's why I'm setting the linkage as word. Now let's predict the output. Model fit predict XPCA. This is almost equal to fit transform. In that case, it will just fit and transform the data. Here, it will just fit and predict for the data. Okay, let's run this. So it will store the output here. Now we need to display these points as a graph. Let's use this as a reference. We don't have a third cluster here, so we will just remove this centroid and the third cluster. Let's run this now. So we have only two clusters here. So you can say this is satisfied. So you can say this is dissatisfied and this one is as satisfied. That is above and neutral. Like that, we can combine the clusters. Before in the elbow method, we have three outputs, that is neutral, dissatisfied, satisfied. That is based on our requirements and assumptions only. If you are doing this for some projects means the requirements vary. Based on the requirements, the number of clusters also vary. You need to find the best number of clusters based on the requirements. Let's see the number of points belongs to each cluster. So counter of y. So as you can see for cluster 1, it has like 3500 points, and for cluster 2 we have 2300 points here. And this concludes our analysis in the dataset. So we have explored various methods, and the hyperparameters you need to change in different types in order to get some different results. If you are doing some contests or working as a professional means, you definitely need to infer with various hyperparameters. So each different hyperparameter gives a different results. So we can get some new inference from each of the models. If you have some different way of approach and some additional inference means, please leave a comment below. It will be very useful for the community. And that's it, guys. If you like this video, hit the like button and don't forget to subscribe the channel for future videos. See you guys with a new project.